video to start. It is started. So we have homework for today, don't we? Bisection method. Let's do this. Now, this is exciting. Here, I just want to encourage you. Those first couple of sections, you know, every time I teach this course, which is only once every 3 years or so, maybe 2 years to 3 years, I always wrestle with whether or not to bother with that. And this time I did, and I kind of regret it. And because it's stuff that I could just introduce later, because, you know, it's good to know sort of speeds, but now at least when we talk about the bisection method being a slow convergence and another method like Newton's method being faster, you have sort of a sense of what that even means. You get more digits quicker with Newton. But let's talk about bisection. Oh, this isn't bisection. So what issues did you have with this homework? Let's see, maybe we could start. It seems like there were 2 types of questions. There was the type where you're just supposed to find, wait a minute, where am I? Oh, wait, I'm way off. Oh, I'm going the wrong, I'm sorry, I'm spinning my wheel the wrong way. Yeah, I was telling my first 2 classes that, yeah, that my mind is not exactly where it should be. Just a minute. Here it is. Okay, there it is. Yeah, so, but I was practicing. I said, we're going to do, like every time we had something to calculate, I said, I'll do it in my head, you know, like some calculus thing and see if I get it right. And I got most of them right. So that was encouraging that even if, you know, I'm not totally focused, it's still working. Okay, so it seemed like there were 2 types of problems. There's the type which says, do the bisection method. And then there's the type that says, how many times are you going to have to do it? So let's deal with the doing of the bisection method first and see if we can knock those out. And then we'll talk about the whole, how long is it going to take and how quickly can we expect this to converge? So so what about the doing? Is there any with the nuts and bolts that we need to take a look at? Wow, really? It was that easy? Let me just get this back up here. There we go. Now I can write, see which side. I can write over here. There's the circle. Wow, so the doing is fine. You're good with the doing? Bisecting? Can't we bisect something? Is there anything that we can bisect? I'm okay not. Wasn't there one of these that was hard, or they were all easy? They're all basically the same. Okay. All right. Well, maybe we'll have to do some bisection over here, though. So what about these with these other questions that we're not quite doing the bisection? Would any of those need to be talked about? My goodness, you are conspiring to not have any, you know, if we don't have any questions, this is what I think when I go to faculty meetings, is I'm like, please, no questions. Then it gets done early. So, like whenever the chair says, are there any questions? I think, don't ask that. We're faculty, of course there are questions. Okay, so anyway, I'm figuring out how to deal with the homework and so forth. But for now, I'll just assume that you guys all did. I'm going to use these stamps eventually. But if you want a stamp on your, like a check mark or a thumb, which one is which? This is the check mark. Blue is check mark, red is thumbs up. You can do it either on the way out, I guess. Just stamp your paper and be happy. Anyway, just for the bookkeeping, because like I said, I'm trying to adjust things so that I can be more present with what's going on at home. So I'll figure out homework. And I don't know, do I have the homework? I think it's my next class. That I don't even have it on my my web page. Yeah. So last week, if you remember, I was a little scattered. This is now you know why. So I apologize for that, but I'll do my best. Okay, let's move ahead then. So we're going to work on the fixed point method. Let's see if I can get this set up here. So this is pretty straightforward. We talked about it some last time, but here's the basic idea: is that I am trying to solve an equation that looks like this. Solve this: f of x is equal to x. I have some calculators here, because I thought it might be helpful in case you don't have one, because the calculators are actually a better tool for this. We will use Python for all of these. I wanted to go over the methods first, and then we'll deal with the Python and see if we can code these things. But that'll be another day, because yeah, I wanted to do this first. So The ideal thing is one of these graphing calculators. So if you have one of these, that's great. If you don't, I've got a bunch here that all work, hopefully, and I can bring them around. So does anyone want to borrow one of mine? You got one? All right. Let's see if this one works. There you go. Enjoy. Any others we got? Okay, you guys are all math geeks, and so you have the colorful calculator. Do you need a calculator? Or do you have? Yeah, you want one. Yeah, sure. Does that one work? Let me check. On? Yeah, it does. Good. All right. Okay. Well, all right. So we'll get this in a sec. Okay. So the general idea, we did this last time, but I'm going to do it again. And then we're going to see what, yeah, so there's a couple of things that we need to do. So this is the thing. Now, at first, you might say that's not very robust. You know, we want to be able to, the ultimate thing is like with the bisection method, you can solve any equation where you've sandwiched a root. If you have two sides of a root, you can figure out where the root is between the two. So at first glance, this might be a little bit limiting because this isn't any equation, is it? It's just one specific type of equation. But in just a minute, I'll show you how you can take other equations and rewrite them so that they look like this. So let's go ahead and solve this equation. We'll solve, let's see. Oh, this one we did that one already. Give me a sec. Let's do this one. Sine. I think we did cosine last time, so we'll do sine. Sine of x equals x. Let me just show you what this means. Wait a minute. Oh, no, I don't want to do that one. No, okay, how about this? X over 2. Better. Oh, that's the same as your, sorry. Keep changing on you. 2x, 2 sine of x, that's the same. Okay, so 2 sine of x. There's that. It goes up to 2. So this is y is equal to 2 sine of x. And then here is y equals x. So here's the thing that we're looking for is right here. Let me make it nice and bold there. Whoop. And of course, you might say, well, that's not the only place where sine of x equals x. And sure enough, you're going to have another place down here somewhere. And of course, the origin is a place where sine of x equals x. But let's talk about the strategy. The strategy for solving an equation like this is we're just going to repeatedly compute 2 sine of x and hope for the best. Now, you're going to find that in the future, with some of the examples I give you, our hopes will be dashed. But hopefully we can, with some of them, it will work. And then we'll be able to discern when does it work, when does it not work. So we'll start off with this thing. So here's the way this works, is you take a guess. Number one is you make a guess. And so my guess is going to be x equals 1. That's my guess. Seems like a reasonable guess. Look, it's over there. It's somewhere, I don't know. It's before you get to pi, because pi is right here. So 1, you might argue it's probably beyond that, maybe 1.5, 1 point, maybe 2. Doesn't matter. I'm going to start with 1. Number 2, your second thing is, so this is step 1. And eventually, as we go to Python, we're going to be wanting to sort of summarize our methods into sort of these, I don't want to call it pseudocode, but just algorithmically, here's what you do. You do this, then this, then this. That way you can get the computer to do it for you. Because if you can't state exactly what we're supposed to do, how are you going to be able to teach the computer? So start off by trying to write down for a human. So number 2, we're going to compute the 2 times the sine of x. And then number 3 is repeat. Step 2. All right, let's do it. So here's what you do. It's on your calculator. Clear, 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 quit. Make sure that your mode, so first things first, and I will put this up on the screen as well once I get this set up. We want the mode. I'm glad I checked on this calculator. I'll show you why. Let's see, where is my camera? There it is. Okay, there it is. Okay, so you can see that my mode is not set to degree or radians. So make sure your mode is set to radians. Whoops. There we go. Enter. There. So you want your mode. I've got some cheap old. I do have a newer calculator. So if you want to see my TI, this is one of my daughters. Does it have her name on it still? I don't know. But anyway, I bought for college, when she went to college, I bought each of them. Isn't this a nice parting gift? Is to give them a nice calculator. I thought that would be nice. But anyway, um, so each one of them got a calculator. I think this is the middle child, the middle daughter. She said she didn't need it anymore, and I said, I'll take it because it's better than any of mine. I mean, look at that. It's beautiful, isn't it? But anyway, yeah, so I would check the mode. I think it looks the same. Yeah, it looks just fancier, but that one's in radians as well. So make sure you're in radians. That's step one. Okay, now we're in radians. We can quit that. And if you don't know, Matthew, you know how to use the calculator as well? You know how to use it. Okay, good. Yeah, so make sure you're in radians so that you can do this. If you're not in radians, you'll fail. Well, you won't fail. You'll just find the solution for the sine of 2 sine of x. Okay, so now we press 1. Whoops, no, not plus, clear. There it is, 1. Okay, that was the first step. I wonder if I can. Oh, what, the mode? Okay. Here, just a minute. I'm just going to see if I can put both of these up. I don't think I can. Yeah, I don't think I can have them both side by side because of this presentation mode that I'm in. Okay, yeah. So press the mode button and then go down. Make sure radian is black there. See how it's darkened? And if it isn't, you can just use the arrow keys to go to radian and press enter like I just did with degree. So make sure you're in radians and then you quit and then put a 1 in there. That way the 1 is in the memory. Okay, now we're going to do 2 times the sine of the answer. Whoops, I have too many parentheses. So the answer is second and minus, at least on this calculator, but this is what it should look like. 2 times sine of the previous thing, and then you press enter, and you get this. Just pause for a minute. And then you just press enter again, and you can go to town. Enter, 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 and you'll notice that pretty quickly the numbers get closer and closer to the actual answer. In fact, here, let's just hit it a few more times. There, I think that's pretty good. So we've got like 6 or 7 digits, don't we? Looks like it's good, at least to here, I'm guessing. But yeah, so my answer will be 1.8954 or 5. But yeah, so there it is. So that's it. That's fixed point iteration. Now let's go back and talk about exactly what's going on. So this is basically it. So what's going on over here, you can think of this in a couple of different ways. One is that you're just repeatedly trying to compute the 2 times the sine of a number, and eventually it's, you're going to get to that point where it's the correct answer. Geometrically, let's see what geometrically we had. So geometrically, what's going on is this. We start with x equals 1, which is over here. Remember that's that place where this crosses the y-axis or x-axis over here, that's pi. So 1 is clear over here. It's a bad guess, but I need it to be far enough away so this would be more interesting. Okay, so that point is kind of like right there, if you will. That's where x equals 1. But the function is not, the function of x equals 1 was like 1.6 or something, wasn't it? I don't know what it was. It was way up here. Okay. Yes, sorry, I had to think for a minute what exactly happened. Okay, so then what happened was you were like, okay, I'm going to set x equal to whatever number this is. Oh no. So I'm going to make x be this number right here. So essentially what that is it's taking that number, so this number, that's this point, and moving over to the y equals x. You see how you can go over there and say, okay, now that is my new. So this would be x0, that's my initial guess. And then this is x1, is this point right there. And then we repeated the process. So then the second step was to say, okay, I'm going to do the function value at that point. And what that does is it's like, okay, I compute this value down here. And that's the function value at that point. Well, now I'm going to replace my x with that. So I move over to the y equals x curve. And this is x2. And then we repeat. We keep going around and around. So then this thing here is the function value there. And then we have this. I think I've drew this poorly geometrically. It shouldn't get bigger. It should get smaller. Okay, so anyway, we'll pretend that it just gets smaller. So when you, I guess I just wanted to say that when you look at the book and you see these spirals going in, that's what's going on, is geometrically, you keep getting closer and closer to the true answer. The true answer is right there. Okay, so now you might be wondering why it is or how it is that this would at all be useful for, in general, for solving equations. So let's take a look at another example, and we'll go back and do this. We'll do the exact same stuff. Okay, so new example. Let's say that I want to know, when is the natural log of x equal to the sine of x? Is that ever the case? Or better yet, well, no, we'll just leave it like this for now. So if I want to use fixed point iteration, I can't have an equation like this. I need this to be a function equal to x. That's what I need. So essentially, I need to rearrange this equation so that I have some function equal to x. There are two different ways to do that. And I don't care which way we do it. Well, actually, I might care. We're going to find out. I honestly don't know if I care or not. We're going to find out, though. So let's think about the two different ways. Does anyone have a way that I could solve this equation for x? Yeah, what do you think? Yeah, e to the, yeah. So basically you do the inverse of one of the sides. So you could do e to the x, sorry, not e to the x, it's e to the natural log of x is equal to e to the sine of x. Yeah, very good. And now the left-hand side becomes just x. So that's one way we could do this. The other way, of course, is to do the more painful thing, I think, and that is do the arc sine of both sides. Now, arc sine has problems associated with it. Namely, arc sine has a domain that only goes from -1 to 1. So that might be well, I guess it is what it is, but that might be a problem. But that is another option, is you could do the arc sine of the natural log of x is equal to x. Well, let's see what happens with both of these. I honestly don't know. I don't know what this is going to look like. But we'll do the same thing. So I'm going to do those same 3 steps. The only difference is, instead of this, I will put whatever function equals x down here. So we're going to try e to the sine of x first. E to the sine of x. And I'm actually a little bit leery of using x equals 1. No, I'm not. I've changed my mind. I don't have any problems with x equals 1. We'll try it. Actually, well, we'll find out. Let's find out what happens. Okay, so let me just show you on my calculator. So just so you know, that's what I'm going to do. And so here's what it looks like on the calculator. I don't know, I feel like I'm leaning over the edge here. So we put 1 in, and then we do, let's see, e to the, so you find e to the whatever. It's on my calculator, it's above the ln key. So e to the sine of the previous number, is that what we had there? Okay, and we'll close. Let's see, does that, okay, it did work. Okay, it did work. Now let's find out what happens. So we repeatedly press enter just a few times first. Oh, this makes me happy. Oh, it's becoming sad. Oh no, it's like it's bouncing around. Wow. Wow. Oh, now, interesting. It's getting down to a 2 cycle. That's fascinating. That's really interesting. Oh, I love it. That's so interesting. Okay, so we're going to have to, well, let's explore. Let's figure out what this means. So yeah, this actually is this is a behavior that is covered in one of the bonus material in this chapter that I was going to skip, that has to do with chaotic solutions and stuff. But yeah, this is fascinating. Let's try something before we give up on this and try to see what it means. Let's try a different starting point. So instead of starting at x equals 1, you can start anywhere you'd like. That's the thing is, I mean, there might be good guesses and bad guesses, but let's start at 0.5 just to see what happens. And then let's see, can I just do the previous entry? Yeah, okay. Oh no, that's going to do the same thing. We're back into our little cycle here. Okay, let me try another. If we start at 2, I don't know. Second entry, we'll try it. Oh, entry. No, we're back to the cycling. Fascinating. Oh, I must find out. Let's find out what the geometry is. So give me a sec. It'll take a minute. So this is now one of the things that that this may show us. This is I'm glad that this did this. Is that it may be that one of the ways of solving this equation is better than the other. I kind of made fun of this arc sine of ln of that made me scared. But that might be the better way to go about solving this particular equation. But let's see. Let's look at the geometry. So by geometry, I just mean what do these graphs look like? I'm going to type in. I know what. Oh wait, I don't. Well, no. I want to get it on the calculator because my sketches might not be accurate or not be good. So we'll do ln of x. Let's see. Close parenthesis. Sorry, I've got a bunch of crud in here. There we go. And then sine of x. So those two equations, or those two functions, I want to know where they intersect. So sine of x. And then let me just make sure my window makes sense. Whatever. I may have to zoom in. Huh. Interesting. Yeah, that's really interesting. Okay, let me zoom in a bit. Sorry. Zoom box. Okay. Okay, here we go. Okay, I'll show you my picture once it gets done. It's taking its sweet time graphing itself, and we'll see what these look like. Okay, so there's my graph, and just to orient you, see that good there? Why not? The one that's going downward is the sine curve. The one that's going upward is natural log of x. So it must be that there's some sort of a relationship between. Yeah. Oh, you know what I think I need to do is I need to graph I just realized I need to graph the other function because that isn't showing me really what I want. I need to do the e to the sine of x. So bear with me. I apologize. We'll get it done. Let's do e to the sine of x. So I'll do x. Give me a sec. And delete. And then insert e to the sine of x. Okay. Let's see, zoom out, window. It's like I don't use this very much. Give me a sec here. Trying to figure out how to use my own calculator. Okay, I think I got it. Okay, let's put this here. So interesting. Yeah, it's interesting to me that this is such a problem. So there it is. So you can see e to the sine of x is the one that isn't straight. And then the other one. So there must be something about this that causes it to toggle back and forth. So apparently the fixed point iteration is not a good, because it looks to me like the actual answer is pretty close to this little bullseye. And that's x equals 2.13 or so. So what we're going to find, I guess this kind of illustrates what we're going to find is that there are certain functions for which when you try to find that central point, you actually start moving away. I can show you some examples of that. It's pretty easy to come up with an example. So it moves away instead of towards the central node. So this one apparently moves away, but then just sort of sits here and just moves around in a big circle, which is kind of interesting. So you have some cycling going on. So not a good, so this isn't a good function to use for fixed point iteration, but let's try this one. So I want to see if this one works. So give me a minute. So I'm going to do the same thing. I'll start at x equals 1. So just to remind you, press x equals 1. I won't show you. You can do it on your own calculator. and then type this in over here. So the way you get arcsine, so press enter after the 1. Arcsine is the second button and then the sine button. It's sine with a little -1 up top. So arcsine of ln of x, so ln of 1. Ooh, let's see what happens. Enter, enter. Oh, interesting. Okay, so I get a bunch of, this is what I was kind of concerned about this, that you end up with a bunch of zeros. Maybe if I start with 2, let's try starting with 2. And then second entry. Oh, I'm sorry. I messed up here. Let me start fresh. Arcsine, I didn't type my function in correctly of the answer. I have to use A and S. I'll show you. Oh, I get an error, domain error. Yeah, of course, because I think I was thinking that would be the problem, is that the natural log of 0 is not undefined. Okay, so, and that's, yeah. So here's just to show you. Here, I'll show you this, and then we'll see if we can find it, if we can make this work. Maybe that this won't work with this one. Whoops. Okay, so so the problem is that when you put 0 into this function, you get undefined. So let's try 2. And then I've already got the function. There it is. Oh, okay. Negative numbers are bad as well. Let's try quitting. And let's try one more try. I'm going to give it one more go. Let's try 3. Oh. Okay. Yep. It is the problem that I was worried about. So I remember, yeah, just earlier today, I was thinking that's no good. But okay, so apparently this function is no good. So we can't do fixed point iteration with this. Surely we can find something that we can do fixed point iteration with, though. So let us do one more try, and then we'll give up. No, we shouldn't give up. Let's try this. So let's try x squared is equal to e to the negative x. That seems like fun, doesn't it? So we'll do this one. Yeah, that should, there shouldn't be any problems with this. Okay, so step 1, of course. Yeah, the ones that you're going to have to do for your homework, I'm just making these up on the fly, so that may be my problem. But the ones on your homework, you shouldn't have as much difficulty with because they're hopefully pre-vetted, so to speak. So I need 2 different ways that I can solve this so that I have x on one side and some function on the other side. So let's just go over here and we'll make a little line. So pick one. Which one would you like to do first? Which one, huh? I'm sorry. Oh, square root of both sides? Yeah, yeah, we can do that. Square root of e to the negative x. Just worried about plus or minus. So because you have 2 branches. So you could do either one, plus or minus, pick one. Let's do plus for now, and then we could do minus later. By the way, the other one would be the natural log of 1 over x squared. So that's the other one. And the reason why it's natural log of 1 over x squared is because you want to change this to e to the x, so you do the reciprocal of both sides, because e to the negative x is 1 over e to the x. So reciprocate both sides, you get e to the x equals 1 over x squared, and then do natural log of both sides to get that. So those are the 2 options. So let's see if either of those work. I sure hope they do, because this is embarrassing if nothing works, and then it's like, what's the point? So here, let me just type it in. So here's what I'm typing. I type 1 is my first guess. The first guess doesn't have to be 1. It's just the one I'm picking because it's simple to think about. Then I'm going to do x equals, now I'll do e to the, let's see, oh, no, I'm sorry, square root. So I do the square root, I'll show you, of e to the, and then negative, I'm scared of the negative key. I do 0 minus the answer. It's the same thing. If you're not scared of the negative key, that's fine. I have my own foibles, and it's one of my crosses I have to bear. But so yeah, so here, this is what I'm talking about. It's that key down there, that negative. Yeah, it makes me leery, and so that's why I'm this way. Okay, so let's see what happens. Okay, and then we do second entry. Oh, I guess we don't have to do. Oh, this is making me happy. There. So that one does converge, and it converges pretty darn quickly. I mean, I've only pressed enter a few times, maybe 10 times. Yeah, I mean, there's 20 times, and I'm already down to almost every single digit. So after 20 iterations, I've just about got my solution. All right, let's try the other way. So that was the one. Oh, we could do the negative as well. Just a minute. Let me see what happens with the negative branch. So we could do this, negative square root. So this will just be a minor change. I'll start with 1, and then I do the entry, and I change it to the negative. Once again, I'll do 0 minus because I'm scared of the negative symbol. 0 minus. Okay. I think it's, yeah, well, that's all right. Okay. Now let's see. Oh, interesting. Just a minute. This one might not converge. Here's what I'm getting. So there's the first two entries. Yeah, by the way, I think that my hang up with the negative symbol is that in certain computer programming languages, if you put negative in front of a function, it doesn't behave the way that you intend. And so I end up doing 0 minus a lot if I'm using, yeah, I just, because I don't trust the whatever computer programming language it is. Ah, this is great. Yeah, it blows up, doesn't it? So yeah, that's great. No, that's a good example of like where you would fail. You fail because this thing blows up. It gets huge. Like the next entry would be so big you wouldn't be able to contain it on the calculator. Okay, excellent. Let's do the other version, and then we'll talk about like when would it fail, when would it not fail. So let's just try this one over here, just for fun. So so basically, I'm going to start at 1 again. Ooh, no. Do you know what's going to happen if we put 1 into this? Some of you probably do. Yeah, if you put 1 in, yeah, this is going to be problematic because of the natural log. You get 1, natural log of 1 is 0, but then the next iteration, divide by 0. So yeah, so I think I'll just avoid that. Yeah, I don't know if well, no, let's try it. Just don't start at 1. Let's start at 2. That'll be fun. So start at 2, and then we'll do the natural log of 1 over x squared, 1 divided by the answer squared, and close parentheses, enter. Oh, wow. I don't know if anyone did this, but it's really chaotic. It's bouncing around. Does it ever settle down? Weird. That's fascinating. Yeah. So I wonder what the geometry is, but fascinating. Yeah. So there, I wonder, and also I wonder, is it cycling between four different roots or 6 different roots? Yeah, something that if I was a true mathematician, I would be like, oh, we got to do a little research project into that one. But no, this is sufficient. Just to talk about the geometry of why it would fail and why it wouldn't fail. So what's happening? Here we go. Let's draw this. Here is the situation: is you have the line y equals x, and then you have your function. So you have several different options as to what the function might look like. So let me just show you the different things where it for sure is going to diverge. So this is a situation where it will diverge for sure. And I'm sure I could come up with a cubic where this is the case. So if I do something like this, then this will for sure diverge. Now let me just show you why it will diverge for sure. So remember that the way that this works is you pick a guess. I don't care which side. Let's put the guess right here. And then let's see, you get a function value for the guess. And then you go over here to the y equals x line. There's your next guess. And then you go and you can see I'm off the screen already. You might say, well, what if we take a guess to the left? Okay, well, if I take a guess here, Then my function value for the guess is down here. I go over to the y equals x line, and then the function, and you can see that this is going to be going further and further away from the root. So anytime you have the slope being greater than 1, the thing will definitely, so that is the slope of this function, the purple function, if it's greater than 1 at x equals 1, or at the fixed point, I should say. So the other option, there's 2 more options, and then we'll see what homework looks like. Yeah, we're in good time. Okay, so 2 more options. Option number 2. Option number 2. There. This one, I don't know why I put arrows there. Let me get rid of them. This one is the choose your own adventure option. So if this is what your fixed point looks like, so yeah, I'm focused on what the fixed point looks like. So here, the slope at the fixed point is greater than 1. Here, the slope at the fixed point is equal to 1. So the reason why this is the choose your own adventure is if your guess is, if you start with a guess above the fixed point, then you end up going down to your function and then back to the line. It's always function, then line, whoops, function, up, down to the function, over, left, right to the line, down to the function, over to the line. Notice that we're getting closer and closer to the fixed point. So there it will converge. If you're above, if you start below, you have the opposite. Go to the function, then go left, right to the line, then to the function, and you can see this is just going to get further and further away. This is bad, this is good. Then the third option is the one where it always will converge. So here, yeah, this, oh, by the way, this isn't the only picture for slope equals 1. If you have the curve above the red line, then it's the opposite. If you start below, you'll converge. If you start above, you diverge. Okay, and then the final one is the one where we're happy, and that's if the slope is less than 1. So we start off with this y equals x, and then it doesn't matter what this looks like, but it's more interesting if it looks like this. And I guess we saw just a bit ago that it's not guaranteed that you're going to converge, but you're not going to diverge. You might cycle around. But the hope is, here, let me get rid of that. Let's make the slope less than 1. There. So here, you're pretty much guaranteed that you're going to converge because you're just going to always get closer. So you start there, you go to the line, up, down to the line, left, right to, or sorry, up, down to the function, left and right to the line, up and down to the function, whoops, left and right to the line. And I'm pretty much on top of the point right there. So slope less than 1, you converge, or at least you're not going to diverge. Might cycle, which is kind of discouraging. Okay, so let's finish things up. And then, yeah, we need to, I think after this week, I'll be better able to talk about like when the test is, but I'm thinking next Friday. That way you will have had a time to recover from whatever test you're complaining about that's this Friday, which I know someone said they had 4 tests on Friday. Is that really? Okay, 4 tests. So this decreases it by 1. Hopefully, what? No. I've already got the differential equations test printed. So however, so hopefully by next, not this Friday, the Friday after, which I believe is the 7th of February, hopefully we'll have recovered. And honestly, once we push it beyond the 31st, I don't care if it's the week after that, because what that means is that we really can't have 2 tests before the midterm break. You know, we only can have 1, which is fine with me, to be honest, in here, because you guys are all smart, and it took a little while to get over that initial stuff. So it means that we're going to rearrange the syllabus just a little bit, but we'll have the first test probably the Friday of the 7th, because by then we'll have all of our root finding methods done, and we'll have some Python. It'll be fun. Oh, the homework, just so you know, I do have homework. I'll put it up on the screen. It's just 3, 4, and 5. Not all of them. Where is my, there it is. So here, just to show you what it looks like, so that we make sure that it's not something crazy. Here we go. Um, is this the right? Yeah, you can see all these diagrams there. You recognize that, don't you? Okay, getting there. There's lines. Oh, this is the one. So this is the one that talks about the cycling. It's very cool. So if you get bored sometime, you could do that for fun. But the homework is 3, 4, and 5. Just to quickly give an overview. Number 3, it's not all of them. I think I picked a few, like ABC or something. Oh, I went too far. That's 4 and 5. There, 3, fixed points. So you find the fixed points exactly. So what it's asking you to do is it's asking you to actually tell me what the fixed point is. So you're using algebra. Hopefully you can do that. Let's just take a look at one of these. I think that's a typo, by the way. But this one, g of x, letter D, 3x squared plus 5x plus 1 equals x. Nice quadratic. You can all do this, right? You can do it. It's a quadratic. Okay, so set this equal to x, solve. The ones that are going to be a little bit more challenging, I forget which ones I picked, but I made sure that they all were doable. Like this one. This one is a little bit more challenging, but it's not terrible. Basically, you know what to do. If you set this equal to x, notice that the x's will cancel. And then the rest of it is not as painful. You're going to change to exponential form. And then there's a little bit more work to do with the quadratic, but it's not bad. So I didn't do B, though. So that's that one. So when you get to that, all it's asking is for you to find the actual answer using algebra. And then so the method, though, is down here. So this one, you're supposed to find 2 different candidates. You know how we had 2 different versions of solving those equations? So here, you have this equation, x plus cosine of x. You want to find the root? Well, one way to do it, I'll just give you it right now, is to put the x on the other side, or no, the cosine on the other side. So you have x equals negative cosine, and that would be the fixed point thing. You want x equals something. The other way is to solve for this x. So you can try to think through some of these others. How would you rearrange it so you have x equals something? And then the last one is the actual fixed point method, where they give you a function, they give you the initial guess, and you're supposed to do 5 iterations. But if you have a calculator, wherever my calculator is, if you have the calculator, you just keep punching if you want. So that's one nice thing about these calculators, is just keep punching, and you can get as many iterations as you want. But you just have to do 5. And then you can say, does this converge? Keep pressing, you'll figure it out. And that's it. So 3, 4, 5. It's not bad. And like I said, eventually we're going to want to put these on Python. We'll have to talk about convergence rates as well. This, by the way, when it converges, usually converges considerably faster than the bisection method. We'll get to that, though. We'll get to convergence rates when we'll do them all together. So once we have Newton's method. All right, that's it. Let me stop the recording in case you want to come talk, and just let me remind you of 2 things.